Welcome. Find a comfortable position and allow yourself to settle in. Over the next several hours, we are going to explore one car, slowly, quietly, and in great detail. That car is the MK4 Toyota Supra. There is no rush here. Each fact will come to you gently, with a little time to breathe around it. Let the information wash over you, and if sleep finds you before the end, that is perfectly fine. We will begin at the very beginning with the idea, with a decision to build something serious. Development of the A80 Supra began in February of 1989. In the early months of 1989, a team of engineers and designers at Toyota quietly began work on what would become one of the most celebrated sports cars in history. It was a cold, deliberate beginning, not a dramatic announcement. Just a group of people sitting down and asking, what should the next Supra be? The world outside was busy. The late 1980s were a period of prosperity and ambition, and Toyota, already known for building reliable, well-engineered machines, decided it was time to build something that pushed further, something that would carry the Supra name into a new decade with complete confidence. The final design was frozen by late 1990, with physical prototypes appearing in 1991. Once the engineering direction was decided, the design process moved steadily forward. By the end of 1990, Toyota's designers had locked in the final shape of the car, that long hood, the flowing roofline, the wide rear haunches. It was a silhouette that felt purposeful without being aggressive. Prototypes began appearing in 1991, rolling out of development facilities and onto test roads, where engineers could finally feel what they had been drawing and calculating for 2 years. These were the quiet, unglamorous early miles that no one outside Toyota would ever see. But they were essential. Every vibration, every cornering sensation, every gear change informed the car that would eventually go on sale to the public. Official mass production of the A80 Supra began in April 1993 in Japan. After roughly 4 years of development, testing, and refinement, the production lines began to move. In April of 1993, the first MK4 Supras rolled off the assembly line in Japan. There was a quiet significance to that moment. The transition from prototype to production, from engineering exercise to real object that real people would own and drive. The cars built in those early months were meticulously assembled, reflecting the level of attention that Toyota had invested in the project from the very start. For the engineers who had spent years on it, April 1993 marked the end of one chapter and the quiet beginning of another. The MK4 was produced from 1993 to 2002, making it the 4th generation Supra. The A80 Supra had a production run of 9 years, from 1993 all the way through to 2002. That is a long time for a sports car to remain in production without a complete overhaul. and it speaks to how well the original design was executed. The car launched in a strong position and remained there, aging gracefully through the decade rather than being replaced or significantly revised. Over those 9 years, incremental updates were made, certain trims changed, specifications were adjusted for different markets. But the fundamental car, the thing Toyota had engineered in those early development rooms in 1989, remained largely intact from the first car to the last. The MK4's internal chassis code is JZA80. Every Toyota has an internal code, a short combination of letters and numbers that identifies the car within the company's own filing system. For the MK4 Supra, that code is JA80. It is the kind of designation that means nothing to most people, but becomes deeply familiar to those who spend time with the car. Mechanics use it. Parts catalogs use it. Forums dedicated to the car are built around it. The JZA80 is not just a label. It is a precise identifier, a shorthand that collapses the entire engineering story of the car into 5 characters. The code breaks down as follows. JZ refers to the engine family, A denotes the Supra model line, and 80 indicates the body generation. Each section of that code carries its own meaning. The JZ prefix points to the engine. Specifically, the JZ family of inline-6 engines that Toyota had developed, which would go on to power several of their most capable vehicles. The A is the Supra's own identifier, a letter that had traveled through every generation of the car. And the 80 marks where this Supra sits in the sequence of body generations. Together, those 3 elements tell you exactly what you are looking at. A JZ engine Supra, 4th in the line. It is a simple system, and once you understand it, the code reads almost like a sentence. The A80 continued a lineage that stretched from the A40 through the A60 and A70, and finally to the A80. The Supra did not begin with the MK4. It had a history behind it, a line of cars that had each carried the chassis code forward by 20. The A40 came first, then the A60, then the A70. Each generation had built on what came before, refining the formula, improving the performance, sharpening the identity of the car. By the time the A80 arrived, the Supra had already spent more than a decade establishing itself. The MK4 inherited that history and added to it. There was a continuity to the Supra story, a quiet accumulation of purpose and refinement that the A80 represented the peak of. The A80's platform was a shortened version of the architecture shared with the first-generation Lexus SC. Beneath the body of the MK4 Supra lay a platform that it shared, in modified form, with another Toyota product, the first-generation Lexus SC, a Grand Touring coupe that had launched in 1991. Toyota had shortened this platform to suit the proportions and handling targets of the Supra. Sharing architecture across models, is a common and practical engineering approach. It allows development costs to be spread across multiple vehicles, while still permitting each car to be tuned distinctly. The Supra and the Lexus SC were related, but they were not the same. Different weights, different intentions, different characters. The shared bones gave the A80 a strong, well-developed foundation to build from. Toyota engineered the A80 as a serious high-performance car from the very beginning of the project. From the first meetings in February 1989, the intention was clear. This was not going to be a softened, compromised sports car, built with one eye on the parts bin and another on the budget. Toyota's engineers set out to build something that could compete at the highest level, something with genuine power, genuine handling, and genuine build quality. That commitment shaped every decision that followed. The engine choice, the suspension design, the structural approach, the braking system. All of it was driven by a consistent ambition to produce a car that was unambiguously fast and capable. That seriousness of purpose is something that comes through even now, decades later, when you look closely at how the car was put together. The body was built as a steel monocoque liftback, a construction that gave the car exceptional rigidity. The MK4 Supra was built around a steel monocoque, a type of construction in which the body and the chassis are a single integrated structure, rather than a separate frame with a body mounted on top. This approach, when executed well, produces a car that is both light and stiff. Stiffness matters enormously in a high-performance vehicle. A rigid structure transmits road information accurately to the driver, responds predictably to steering inputs, and provides a stable platform for the suspension to work against. The liftback body style, with its large rear glass hatch that opened to reveal the cargo area, added practicality without compromising the structural integrity of the shell. The result was a foundation that could absorb the demands of serious performance driving without flex or complaint. And with that, we have laid the first stones of the story. The MK4 Toyota Supra began not on a road and not in a showroom, but in a meeting room in 1989, with a decision to build something that would endure. Over the rest of this video, we will move through every layer of that car, from its engines to its exterior, from its production numbers to the small details that most people never notice. But for now, let these first 10 facts settle quietly. The development years, the frozen design, the lineage, the monocoque body, and the code that names it all. Let them sit with you as you rest. There is much more still to come, and none of it is going anywhere. And now we move into the second part of our journey, through the MK4 Toyota Supra. If the first segment was about the idea, the decision, the lineage, the foundation, then this one is about something more deliberate, more precise. This segment is about weight, about the quiet, methodical way that Toyota's engineers went through every part of the car, one by one, and asked the same question each time. Can this be lighter? It is a process that does not make for dramatic headlines, but it shapes everything about how a car moves, how it feels, and how it performs. Settle in, and let's move through it slowly. Engineers reduced the weight of the A80 by roughly 200 pounds compared to the previous generation Supra. 200 pounds is a significant reduction for any car to achieve between generations. The A70, the MK4 Supra that preceded the A80, was a capable car, but it had grown heavier over the years, as cars often do when they accumulate features and refinements across a long production run. Toyota's engineers were determined not to carry that weight forward, so they started again with fresh intent, approaching the new car with a target in mind, rather than simply accepting whatever mass the design happened to produce. The result of their work was a car that felt more alert, more responsive, and more alive than its predecessor. That 200-pound difference was not achieved in one place. It was the sum of dozens of small decisions, made quietly and carefully, across the entire vehicle. Aluminum was used for the hood, the roof, the bumper supports, and various suspension components. Rather than defaulting to steel for every panel and structural piece, Toyota selected aluminum for several key areas of the car. The hood, one of the larger body panels and one that sits directly over the heavy front-mounted engine, was aluminum, which removed meaningful mass from exactly the place where mass is most damaging to handling balance. The roof was also aluminum, keeping the center of gravity low by reducing weight at the top of the car. Bumper supports and suspension components followed the same logic. Each aluminum piece replaced something that would otherwise have been steel, and each one shifted the car incrementally in the right direction. Lighter, better balanced, more capable. The front subframe section was constructed from alloy. Even the structural components that most drivers would never think about, the pieces that live beneath the car and hold the suspension geometry in place, received the same scrutiny. The front subframe, which connects the front suspension to the body and takes on significant loads during cornering and braking, was built from alloy rather than conventional steel. This was not a simple substitution. Alloy subframes require careful engineering to ensure they are strong enough to handle the stresses placed on them, while still being light enough to justify the material choice. Toyota's engineers managed that balance, producing a component that was both structurally sound and meaningfully lighter than an equivalent steel part would have been. Even the steering wheel frame was constructed from magnesium alloy. The weight-saving effort extended all the way into the cabin. The structural frame of the steering wheel, the internal skeleton that sits beneath the leather and padding, was made from magnesium alloy, one of the lightest structural metals available. By itself, the weight saved by a magnesium steering wheel frame is very small, but that is precisely the point. Toyota's approach to weight reduction was not to find one large saving and stop there. It was to find savings everywhere. In the cabin, under the hood, beneath the car, in the panels, in the structure. The steering wheel frame was simply one more item on a very long list. Hollow fiber, low-pile carpeting was specified throughout the interior to reduce mass. The interior of the A80 Supra was trimmed with a specific type of carpeting chosen partly for its weight. Hollow fiber, low-pile carpet, a material that uses hollow strands rather than solid ones, is lighter than conventional carpet of comparable thickness. On its own, the difference is negligible. In the context of a car where the engineers were counting grams in the steering wheel frame, it fits perfectly. Every surface in the car, every material choice, was evaluated not only for feel and appearance, but for mass. The carpet you sat above, the ceiling liner above your head, the door cards beside you. All of it was considered through the same lens of careful, patient weight reduction. Even the engine head bolts were lightened as part of the weight reduction program. This is perhaps the most telling detail in the entire weight-saving story. The engineers went so far as to specify lighter head bolts, the fasteners that clamp the cylinder head to the engine block. These are components that most people would never think to examine, let alone modify in the name of saving mass. But Toyota's engineers examined them. They looked at the entire car, including the engine internals, and found ways to reduce weight without compromising function or reliability. It speaks to a completeness of approach that goes well beyond surface-level effort. When a manufacturer is specifying lighter head bolts, they are not cutting corners. They are being thorough in a way that is almost meditative. A plastic fuel tank was used in place of a heavier metal unit, reducing the car's overall mass. The fuel tank, typically a straightforward metal component tucked away at the rear of the car, was another target for the weight reduction program. By switching to a plastic tank, Toyota removed additional mass from a part of the car that had previously been taken for granted. Plastic fuel tanks were not unusual by the early 1990s, but specifying one here was consistent with the broader philosophy. Examine every component, evaluate every material, and choose the lighter option wherever it can be done without sacrifice. The plastic tank also resists corrosion in a way that a metal tank cannot, offering a quiet secondary benefit alongside the primary one. A single large diameter exhaust system replaced a heavier dual pipe arrangement. Earlier performance cars often used dual exhaust systems, two separate pipes running from the engine to the rear of the car, which added visual drama and a certain mechanical impression of power. Toyota took a different approach with the A80. A single large diameter exhaust was specified, which could flow exhaust gases efficiently while weighing less than a dual system would have. It was a practical decision and a considered one. The single exhaust was tuned to complement the engine's characteristics rather than simply being chosen for its appearance. The result was a cleaner undercar layout, a meaningful weight saving, and an exhaust note that was direct and uncluttered. The resulting weight distribution was approximately 51% front to 49% rear. All of that careful, methodical weight reduction produced a car with near perfect balance. A 51 to 49 front to rear weight distribution is very close to the ideal for a performance car, close enough that the difference is essentially imperceptible in normal driving. This balance means that the car is not asking the front tires to do too much and not asking the rear tires to do too much. The loads are shared almost equally across all four contact patches, which makes the car more predictable, more composed, and more rewarding to drive at any speed. That number, 51 to 49, is the quiet payoff for every gram saved in every component, right down to the head bolts and the steering wheel frame. The turbocharged manual variant had a curb weight of approximately 3,450 to 3,460 pounds. With all of that effort applied, the production turbocharged Supra with a manual gearbox came in at approximately 3,450 to 3,460 pounds. By modern standards, that is not a particularly light car. Today's sports cars often use advanced composites and aluminum-intensive construction to go considerably lighter. But in 1993, for a car of this size, this capability, and this level of equipment, it was a well-controlled figure. It was the weight of a car that had been thought about seriously, managed deliberately, and brought to market in a condition that its engineers could be satisfied with. Every pound on that scale had been examined. Most of the unnecessary ones had been removed. That is the second chapter of the Supra's story. Not the most dramatic chapter, perhaps, but one of the most telling. The obsession with weight and balance reveals the character of the people who built this car. They were not satisfied with good enough. They went further than they needed to, into details that no buyer would ever read about in a brochure. And the result of all that quiet work was a car that sat almost perfectly level between its front and rear wheels, ready for whatever came next. And what came next was the heart of it all. The thing that made the MK4 Supra a legend in its own time. Allow yourself to rest a little more deeply as we approach it. And here we arrive at the engine. If the previous segment was about the careful, patient work of removing weight from every corner of the car, then this one is about what sat at the center of all that effort. The thing the car was built around. The reason the weight reduction mattered. The reason the balance mattered. This is the 2JZ. Few engines in automotive history have earned the kind of enduring reputation that this one has. And over the next several minutes, we will move through it slowly and let the details settle. There is no need to rush. The engine has been turning for over 30 years. It will wait for us. The MK4 Supra introduced the 2JZ engine, a 3.0-litre inline-six that Toyota had developed with both performance and longevity in mind. It was a new engine for a new car, and it arrived with the kind of overbuilt construction that would define its legacy. A 3.0-litre displacement was substantial for a sports car of the early 1990s, and the inline-six configuration allowed Toyota to extract that displacement in a way that was both powerful and refined. The 2JZ was not simply dropped into the Supra as an available option. It was the engine the car had been designed around. Everything else, the platform, the weight distribution, the structural choices, existed in service of this engine and what it could do. The 2JZ came in two distinct forms. The naturally aspirated version was designated the 2JZ-GE, and it powered the base Supra models. The twin-turbocharged version, the one that would become legendary, was the 2JZ-GTE. Both engines shared the same fundamental architecture, the same block, the same bore and stroke. But the GTE added a sequential twin-turbocharger system that transformed the engine's character entirely. Where the GE was smooth and linear, the GTE was something more, a machine that built power with purpose and delivered it in a way that felt both substantial and composed. The two variants offered buyers a choice: one engine for those who wanted the Supra's shape and platform without the full weight of its performance, and another for those who wanted everything the car could offer. At the foundation of both variants was an iron engine block featuring 7 main bearings. In most engines of this era, 5 main bearings were the standard. 7 was unusual, an engineering choice that went beyond what was strictly necessary for a production car. Main bearings are the supports that hold the crankshaft in place as it spins, and more of them means more support, less flex, and greater rotational stability at high engine speeds. The 7-bearing arrangement gave the 2JZ a crankshaft that was exceptionally well supported, which contributed directly to the engine's reputation for surviving enormous power outputs without internal failure. It was the kind of over-engineering that reveals intention. Toyota built this engine to last, and to take more than the factory asked of it. In the United States, the twin-turbocharged 2JZ-GTE was officially rated at 320 horsepower and 315 pound-feet of torque. These were the numbers that appeared in brochures and specification sheets, and they were honest ones. For 1993, 320 horsepower from a production sports car was a serious figure. It placed the Supra in direct competition with the fastest production cars available at the time. And it did so with an engine that was extraordinarily smooth and refined for its output level. The 315 pound-feet of torque arrived across a wide and accessible rev range, making the car feel strong and capable in everyday driving, as well as at the limits of performance. Those numbers told a story of balance, not a single-minded pursuit of peak power, but a carefully considered combination of power and usability. In Japan, the story was slightly different. The Japanese market twin-turbo Supra was officially rated at 276 horsepower, a number that bore little relationship to what the engine was actually producing. This was the result of what had become known as the Japanese Domestic Market Gentleman's Agreement, an informal understanding among Japanese automakers in the early 1990s not to officially advertise more than 276 horsepower in their home market. The intent was to avoid a public perception of escalating performance competition among manufacturers. In practice, the 276 horsepower figure was a ceiling on paper only. The engines producing that number were widely understood to be significantly more powerful in reality. The Supra's Japanese specification was, in all measurable ways, the same engine as the one sold elsewhere. The number was a formality, and everyone involved understood it as such. Later in the A80's production life, the 2JZ GTE received an update in the form of Toyota's variable valve timing with intelligence system, known as VVTi. This technology allowed the engine to adjust the timing of its intake valves based on driving conditions, optimizing combustion efficiency across a broader range of engine speeds. The practical result was an increase in torque, which rose to 338 pound-feet in the VVTi equipped models. The additional torque made the later Supras feel even more effortless in regular driving, pulling from lower in the rev range with a smoothness and ease that made the engine's capability feel almost understated. The facelift that introduced VVTi also brought other refinements, but it was this torque increase that enthusiasts noticed most readily behind the wheel. A turbocharged Supra with a manual gearbox could accelerate from 0 to 60 miles per hour in approximately 4.5 to 4.8 seconds. That figure placed it among the quickest production cars available when it was new. The acceleration was not just fast in absolute terms, it was fast in a particular way. The sequential twin turbocharger system, which used a smaller turbocharger at lower engine speeds and a larger one higher in the rev range, produced a power delivery that built progressively rather than arriving in a sudden, disruptive surge. The car felt strong from a standstill, stronger through the mid-range and then very powerful at higher revs. That progressive quality made the performance feel accessible, manageable, and deeply satisfying to explore. The top speed of the MK4 Supra was electronically limited to 155 miles per hour, or 250 kilometers per hour. This limit was not a reflection of the engine's capability. The 2JZ GTE was widely understood to have significantly more velocity available than the limiter allowed. Rather, the 155 miles per hour figure was another product of the Gentleman's Agreement era, an informal speed ceiling that Japanese manufacturers voluntarily observed in the 1990s. The limiter was a software constraint, not a mechanical one. Beyond that ceiling, the car and its engine were fully capable of continuing. But in standard production form, 155 miles per hour was where the electronics intervened and held the car steady. It was, in its own way, a very polite upper boundary for a machine of this capability. The inline-six configuration of the 2JZ contributed something to the driving experience that is difficult to quantify, but impossible to miss: smoothness. A straight-six engine is inherently balanced in a way that other configurations are not. Its firing intervals are perfectly even, and its primary and secondary vibrations cancel each other out naturally, without the need for additional balance shafts or engineering workarounds. The result is an engine that spins with a quality that feels almost frictionless, a turbine-like refinement that persists right through the rev range. In the Supra, that smoothness was ever present. Whether the engine was idling quietly at a standstill or spinning hard under full acceleration, it never felt rough, never felt strained. It simply turned, smoothly and completely, as though this was something it could do forever. Toyota's maintenance guidelines for the 2JZ recommend that the timing belt be changed every 50,000 miles. The timing belt is a critical component. It synchronizes the rotation of the crankshaft and the camshafts, ensuring that the engine's valves open and close at precisely the right moments relative to the pistons. If the belt fails, the consequences can be severe. Toyota's 50,000-mile interval reflects the company's conservative approach to maintenance scheduling, erring on the side of caution to protect an engine that was built to last. Owners who follow that interval and maintain the engine carefully have found that the 2JZ is remarkably durable, capable of accumulating very high mileage without requiring major internal work. It is an engine that rewards attention and repays it generously. The 2JZ engine is why the MK4 Supra endures. Other cars from the same era have faded, remembered fondly by their owners perhaps, but not studied, not sought after, not discussed with the same sustained intensity decades later. The Supra has not faded, and at the center of that endurance is this engine: the iron block, the 7 main bearings, the twin turbos, the smooth inline-6 rotation. It is a piece of engineering that arrived fully formed and has never been bettered in the eyes of those who know it well. Let that settle for a moment. The smooth sound of an inline-6 turning quietly somewhere in the distance. There is more of the car still to come. We have spent some time with the 2JZ as Toyota built it. The factory specifications, the official numbers, the careful engineering choices that went into its original design. Now we go a little further. Because the story of the 2JZ is not only the story of what Toyota intended, it is also the story of what the engine turned out to be capable of when people began to push it beyond its original boundaries. And that story is, in its own quiet way, extraordinary. Settle in a little more, and let's move through it together. From the very beginning, the 2JZ GTE was deliberately over-engineered. That word, over-engineered, is not a criticism. It is a precise description of an approach in which the components of a machine are built to tolerances and strengths that exceed what the machine's intended use would require. Toyota designed the 2JZ to produce a specific amount of power in a production sports car. But the materials they chose, the dimensions they specified, and the construction methods they employed resulted in an engine that was capable of handling significantly more than that. The 7 main bearing iron block, the forged internals, the robust head design, all of it added up to a foundation that was stronger than a 320 horsepower engine needed to be. That surplus strength turned out to be one of the most consequential decisions in the history of performance engines. In practical terms, what this means is that the 2JZGTE can handle in excess of 600 horsepower on its original unmodified internal components. The pistons, the connecting rods, the crankshaft, the parts that live inside the engine and absorb the forces of combustion, were built with enough margin that doubling the factory power output does not push them beyond their limits. For the people who modify these cars, this is an almost unheard of starting point. Most engines, when asked to produce power far in excess of their factory rating, require internal reinforcement before they can do so reliably. The 2JZ does not. The factory internals simply continue to function, absorbing the additional stress without complaint. Some modified setups have taken that figure further still, to 700 horsepower and beyond, all while leaving the bottom end of the engine entirely untouched. The bottom end refers to the lower half of the engine, the block, the crankshaft, the connecting rods, and the pistons. Leaving it untouched while producing 700 horsepower is a statement about the original engineering that is difficult to overstate. It means that the factory crankshaft is spinning under loads it was never explicitly designed for, and doing so without failure. It means that Toyota's original component specifications had margin built into them. Margin that the engineers may not have fully intended for public use, but margin that exists regardless and can be drawn upon by anyone willing to explore it. When builders do choose to open the engine and replace the internals with stronger aftermarket components, a process known as a full build, the 2JZ responds with capabilities that move into genuinely extreme territory. Fully built examples regularly produce in excess of 1,000 horsepower. The engine's external dimensions, its cylinder head design, and its overall architecture can accommodate the fuel, air, and combustion pressures required to reach those figures without the kind of fundamental compromise that limits other platforms. A 4-figure power output from a 3.0-litre inline-6 is an extraordinary achievement, and the 2JZ reaches it with a reliability and repeatability that has made it the default choice for serious high-power builds for over 3 decades. At the very extreme end of what has been accomplished, there are drag detail-oriented builds that have produced approximately 1,800 horsepower from a 2JZ-based engine. These are machines that exist far outside the boundaries of road use, purpose-built racing cars in which the engine has been modified so extensively that very little of the original factory specification remains beyond the basic architecture. The block is reinforced. The head is heavily modified. The fuel system is rebuilt entirely, and the turbocharger or turbochargers involved bear no resemblance to anything Toyota ever fitted. But the fact that the 2JZ is the platform these builders choose, even at this extreme level, says something about the engine's fundamental integrity. When you are building a machine to produce 1,800 horsepower and you need a starting point you can trust, the 2JZ is where many of the most experienced people in the world begin. The quarter-mile performance of these extreme Supra builds reflects what those power figures can produce. There are 6-second quarter-mile Supras, cars that cover a quarter of a mile from a standing start in under 7 seconds. To understand what that means in physical terms, a 6-second quarter mile requires an average speed across the run of well over 150 miles per hour. The car reaches that average by accelerating with a ferocity that is difficult to describe in calm terms. These are not cars that most people will ever drive or stand beside or watch in person, but they exist, and they were built from the same basic engine architecture that Toyota first described in our product brochure in 1993. On the other end of the speed spectrum, not acceleration, but outright velocity, manual transmission Supras have been recorded, exceeding 240 miles per hour. Top speed runs of this kind require not only enormous power, but exceptional aerodynamic stability and structural integrity at speeds that very few road-derived cars ever reach. The fact that the MK4 Supra's body and platform can be adapted for runs of this kind, and that the drivetrain can survive them, is a testament to how well the original car was put together. 240 miles per hour is a number that belongs to a small and select group of machines. The Supra sits within it. Returning to the factory specification for a moment, the original Japanese market twin-turbo Supra used ceramic turbine shafts in its CT20A turbochargers. Ceramic was chosen for its low thermal mass, meaning it heats up and cools down faster than metal equivalents. This characteristic is directly responsible for one of the two JZGTE's most admired qualities: turbo spool time. The ceramic shafts in the small primary turbocharger allowed it to begin spinning and building boost pressure very quickly, which reduced the lag that drivers typically experience between pressing the accelerator and feeling the turbocharger's contribution to power output. In everyday driving, that quick spool time made the car feel more responsive and more immediate than many turbocharged cars of the same era. However, the ceramic turbine shafts had a significant limitation. While they performed very well under normal operating conditions, they were fragile when subjected to the mechanical stresses and elevated boost pressures that come with performance modification. Ceramic is a hard but brittle material. It resists heat well, but does not flex. Under high boost, or after the kind of hard, repeated use that a modified car is subjected to, ceramic turbine shafts can fracture. A fractured turbo shaft is a terminal failure. For the turbocharger, and the resulting debris can cause damage that extends further into the engine. For owners running the car in its factory configuration, this was rarely an issue. For those pushing the car harder, it was a risk that needed to be managed. The response from the modification community was straightforward. Replace the ceramic turbos with steel alternatives, or abandon the twin-turbo setup altogether in favor of a single large turbocharger conversion. Steel turbine shafts are far more tolerant of high boost pressures and mechanical stress, making them the practical choice for modified cars. The single turbo conversion became particularly popular, replacing the sequential twin-turbo arrangement with a single larger turbocharger that could flow more air at the higher boost pressures required for big power builds. Both solutions address the fragility of the factory ceramic shafts, and both remain common choices today among Supra owners looking to build on the engine's extraordinary foundation. And so the picture of the 2JZ becomes complete. It began as a carefully engineered production engine, built with more strength than its factory role required. It was then discovered, tested, and pushed by a generation of enthusiasts who found that its limits were far higher than anyone had officially stated. It survived 600 horsepower on stock internals, 700 horsepower without opening the bottom end, 1,000 horsepower with careful preparation, and 1,800 horsepower in the hands of the most dedicated builders in the world. It reached 240 miles per hour on a straight road. It ran the quarter mile in 6 seconds, and through all of it, the basic architecture. That iron block, those 7 main bearings, that smooth inline 6, remained at the center. But all of that power, those extraordinary numbers, meant nothing without something to manage it. Without a chassis, a suspension, a braking system that could take what the engine was giving and turn it into something a driver could actually use and control. The engine produces power, but power on its own is only half of the story. Before any of it reaches the road, it has to pass through a gearbox, a collection of precisely machined shafts, gears, and bearings that translate the engine's rotational output into forward motion. The gearbox is the connection between the engine and the wheels, and in a car as capable as the MK4 Supra, the gearbox matters enormously. This segment is about the transmissions that Toyota chose for the A80 and about why some of them have become legends in their own right. There are only a handful of facts here, but each one carries enough weight to fill the space around it comfortably. Let's move through them without hurry. The turbocharged manual Supra used a gearbox built by the German manufacturer Getrag, specifically a unit designated the V160. It is a 6-speed manual transmission, and it has, over the decades since the Supra's introduction, acquired a reputation that places it among the most respected production gearboxes ever fitted to a road car. Getrag had a long history of building high-quality manual transmissions for performance applications, and the V160 represented their work at its finest. It was designed specifically for the loads and power outputs that the 2JZ would produce, and it was built to the kind of tolerances that allowed it to shift with a precision and mechanical satisfaction that drivers remember for a long time. The action of the lever, the weight of the clutch, the way each gear engaged. The V160 gave the turbocharged Supra a driving experience in which every gear change felt considered and complete. It was not simply a component chosen to do a job. It was a gearbox that elevated the act of driving. The V160's internal layout is worth examining in detail because it contains a characteristic that sets it apart from the majority of 6-speed gearboxes built in the same era. Most gearboxes of this type are designed so that their top gear, whether 5th or 6th, is an overdrive ratio, meaning the output shaft spins faster than the input shaft. This reduces engine revs at cruising speeds, which is good for fuel economy and refinement. The V160 went further. It features what is known as a double overdrive layout. 5th gear is a 1-to-1 ratio. In 5th, the output shaft spins at exactly the same speed as the input shaft, which is itself already a relatively relaxed engine speed. Then 6th gear drops further still, to a ratio of approximately 0.8-to-1. This means that in 6th gear, the output shaft is spinning faster than the input shaft by a significant margin. The engine is turning slowly, while the wheels are turning relatively quickly. The practical effect is a motorway cruising gear, in which the engine barely has to work. Highway revs in 6th gear are low, unobtrusive, and easy on fuel. The 2JZ, already a smooth engine at any speed, becomes almost imperceptible in 6th, a quiet hum in the background while the car covers ground with complete composure. Today, the Getrag V160 is extremely rare and commands prices that reflect both its scarcity and its desirability. Because the V160 was produced specifically for the MK4 Supra and fitted to a relatively limited number of cars over a production run that ended more than 2 decades ago, the supply of used units is finite and shrinking. Gearboxes wear. Some are damaged. Some are parted out for individual components that are needed elsewhere. The pool of available V160 units gets smaller over time, and the pool of people who want one, or whether to restore a Supra, replace a worn unit, or adapt one for use in another vehicle, does not shrink at the same rate. The result is a gearbox that can command several $1,000s in good condition and significantly more for units that are in excellent low mileage shape. It is a curious thing, a car part that has become a collectible, sought after and carefully preserved in a way that would have seemed improbable when it was simply a component on a production line in the early 1990s. For buyers who chose the automatic transmission option, the weight penalty was remarkably small. The turbocharged Supra, fitted with an automatic gearbox, weighed only approximately 10 pounds more than the equivalent manual car. 10 pounds across a vehicle weighing more than 3,000 pounds is a difference that is essentially imperceptible in any practical sense. It is a rounding error in the weight distribution calculations, a figure that would not register under normal driving conditions. The narrowness of that gap reflects how carefully Toyota had engineered the automatic option, not as a compromise or a concession to buyers who preferred convenience over engagement, but as a genuinely considered alternative that delivered the car's performance with only the most minimal impact on the characteristics the engineers had worked so hard to establish. The automatic Supra was not a lesser car by weight. It was, by that particular measure, almost identical. The automatic turbo Supra used a system Toyota, designated ECT-ISS, the initials standing for electronically controlled transmission with intelligent sport. It was not a simple automatic gearbox that shifted through its ratios on a fixed schedule. The ECT-IS was adaptive. It monitored the driver's behavior, the rate at which they pressed the accelerator, the speed at which they were traveling, the frequency and urgency of their inputs, and adjusted its shift patterns accordingly. A driver using the car gently, in relaxed everyday conditions, would find the transmission shifting smoothly and early, keeping engine revs low and the experience unhurried. The same driver, accelerating harder or taking a corner with more intent, would find the transmission holding gears longer, downshifting more readily, and generally behaving as though it understood that something more purposeful was being asked of it. This kind of adaptive transmission behavior was not uncommon in luxury cars of the era, but finding it in a sports car, tuned specifically for performance driving rather than just comfort, reflected the seriousness with which Toyota had approached every aspect of the A80. The naturally aspirated Supra, the non-turbocharged model fitted with the 2JZGE, was frequently paired with Toyota's W58 5-speed manual gearbox. The W58 was a capable and well-regarded transmission in its own right, having been used in various Toyota performance models across several generations. However, it was not designed for the kind of power that the turbocharged 2JZGTE produced, and it is generally considered a weaker unit than the V160 when subjected to significant power increases. for owners of naturally aspirated cars who chose to add forced induction or otherwise increase the engine's output beyond standard levels, the W58 often became a limiting factor, a gearbox that needed to be replaced or reinforced before the engine's full potential could be used reliably. This is not a criticism of the W58 in its intended application. For the naturally aspirated Supra, it was designed to serve. It was more than adequate. But it underlines the intentionality of Toyota's decision to fit the V160 to the turbocharged car specifically. A recognition that a different engine with different outputs and different demands needed a different gearbox to match. Taken together, the transmissions fitted to the MK4 Supra tell a story about how Toyota thought about the car's different variants. The naturally aspirated car received a good, proven gearbox, practical, reliable, well suited to its engine. The automatic turbo car received an intelligent, adaptive transmission that brought the car's performance to a wide range of drivers with minimal compromise in weight or character. And the manual turbo car received something exceptional, a German-engineered six-speed with a double overdrive top gear, built to tolerances that have kept it functioning and desirable for over 30 years, and now rare enough that finding a good one requires patience, money, or a great deal of luck. Each transmission was chosen with care. Each one suited its application, and the V160 in particular became something that the car could not be fully separated from in the minds of those who drove it. It was not just how the power was delivered, it was part of the experience itself, and as with the engine it served, all of that power and all of that precision needed somewhere to go. It needed a chassis beneath it that could manage what the engine and gearbox were capable of producing. We have spent time with the engine and with the gearboxes that carried its power toward the road. Now we move outward, to the body of the car, the air that moves around it, and the systems that keep it connected to the surface beneath it. This is a segment about forces, about the invisible pressure of air against a moving body, about the grip of rubber on tarmac, about the geometry of suspension and the mechanics of braking. None of it announces itself loudly when you are inside the car. It simply works quietly and continuously. Every moment the car is in motion. Let's move through it slowly. The MK4 Supra had a drag coefficient that ranged between 0.31 and 0.33, depending on specification. The drag coefficient is a dimensionless number that describes how efficiently a body moves through air. The lower the number, the less resistance the air presents to the object passing through it. For context, a flat plate held perpendicular to the airflow has a drag coefficient close to 1.2. A well-designed production car in the early 1990s might achieve somewhere between 0.30 and 0.35. The Supra sat comfortably within that range, and its variation between specifications reflects the aerodynamic effect of different body configurations, most notably the presence or absence of the large rear wing. A car fitted with a substantial rear wing pushes more air out of the way than one without, and that additional disruption registers in the drag coefficient as a modest but measurable increase. In a car designed for high-speed performance, managing that trade-off between drag and downforce is one of the quieter arts of vehicle development. Speaking of the rear wing, the large spoiler fitted to the turbocharged Supra generated approximately 66 pounds of downforce at 150 miles per hour. Downforce is the aerodynamic force that pushes a car toward the road surface, increasing the load on the tires and therefore the grip available to the driver. At lower speeds, 66 pounds is not a dramatic figure. The forces involved at city speeds are too small to register through the steering or the seat. But as speed increases and the aerodynamic forces grow with the square of velocity, that downforce becomes increasingly meaningful. At 150 miles per hour, a speed the Supra could reach in a matter of seconds from a rolling start. 66 pounds of additional rear-end load represents a real and tangible contribution to stability. The car sits more firmly on the road at those speeds, with a planted, composed quality that the driver feels as confidence rather than force. The rear wing did not work alone. The Supra's liftback body featured a ducktail profile at the trailing edge of the roofline, a subtle upward kick where the glass met the bodywork, that contributed to the aerodynamic package in its own right. Together, the rear wing and the ducktail reduced rear lift by approximately 70% compared to a body without those features. Lift is the aerodynamic force acting in the opposite direction to downforce. It is the tendency of a moving body to be pushed upward and away from the road surface. At high speeds, lift at the rear of a car reduces tire contact, lightens the steering feel, and introduces a looseness to the car's behavior that experienced drivers find unsettling. By reducing rear lift by 70%, Toyota ensured that the Supra remained stable and predictable at the speeds its engine was capable of generating. The aerodynamics were not decoration. They were a functional part of the car's high-speed character. There is one detail about the rear spoiler that most people who have driven or admired the Supra would not know. Built into the structure of the spoiler is a resonance chamber, a hollow cavity specifically engineered to cancel certain frequencies of wind noise at speed. As air moves over and around the spoiler at high velocity, it generates sound. Some of those sounds, if left unaddressed, would find their way into the cabin as a persistent drone or whistle, the kind of background noise that accumulates over a long journey and quietly contributes to fatigue. Toyota's engineers designed a resonance chamber into the spoiler that disrupts those frequencies before they can propagate into the body structure. The result is a cabin that remains quieter at speed than it would otherwise be. It is a small thing, and a completely invisible one. Most people never know it is there, but it is another example of the completeness with which the car was developed, the willingness to solve a problem that most manufacturers would have simply accepted. The braking system of the turbocharged Supra was built to match the performance the engine and gearbox could generate. The front rotors were ventilated discs measuring 323 millimeters in diameter, a substantial size for a production car of the early 1990s. Ventilated rotors use a layered construction with cooling passages running between the two braking surfaces, allowing air to flow through the rotor and carry heat away from the friction material. Heat is the primary enemy of braking performance. As rotor temperatures rise, braking efficiency declines, and under sustained hard use, a poorly cooled braking system can fade to the point where it is no longer effective. The 323mm ventilated rotors gave the Supra a thermal capacity that matched its performance envelope, ensuring that the car could be braked hard and repeatedly, without the kind of degradation that would compromise safety or driver confidence. The anti-lock braking system fitted to the Supra included a feature that was not universally present on sports cars of the era: a lateral G sensor. Standard ABS systems of the period monitored wheel speeds and intervened to prevent lockup under straight-line braking. The lateral G sensor added a dimension to that monitoring. By measuring the sideways forces acting on the car, the forces generated during cornering, the ABS system could adjust its behavior to account for the fact that the car was not traveling in a straight line when the brakes were applied. Braking while cornering places different and more complex demands on the tires than straight-line braking, and a system that does not account for those demands can intervene in ways that are counterproductive. The lateral G sensor allowed the Supra's ABS to be more nuanced, more contextually aware, and therefore more effective across a wider range of real-world braking situations. Period road tests recorded lateral grip figures of between 0.95 and 0.98 G on the skid pad for the turbocharged Supra. The skid pad is a standard automotive testing tool, a large, flat circle of tarmac on which a car is driven at the maximum speed it can sustain without losing grip, and the lateral acceleration at that speed is recorded. A figure of 0.95 to 0.98 G places the Supra in the company of dedicated sports cars and high-performance machinery from the same era. It is not the grip level of a racing car, but it is the grip level of a vehicle that takes handling seriously and has been engineered, from its tires to its suspension geometry, to make the most of the contact patches available to it. Those numbers, recorded on a flat circle, represent a car that could be trusted at high lateral loads, composed, communicative, and willing. The suspension system that produced those figures was a double wishbone arrangement at both the front and rear axles. Double wishbone suspension uses two lateral arms at each corner of the car, an upper wishbone and a lower wishbone, to control the movement of the wheel through its travel. This geometry allows the engineer to carefully specify how the wheel changes angle relative to the road as the suspension compresses and extends, which in turn determines how the tire's contact patch behaves under load. When executed well, double wishbone suspension provides both handling precision and ride quality. It can be tuned to be progressive and predictable under hard driving, while remaining compliant enough for everyday comfort. Toyota's application of this geometry at all four corners of the Supra gave the car a consistency of behavior front to rear that contributed directly to its balance and its reputation for rewarding trustworthy handling. One final figure worth sitting with. The Supra's turning circle was 10.8 meters. Turning circle is the diameter of the circle a car traces when its steering is held at full lock. A smaller number means a tighter, more maneuverable car in confined spaces, easier to navigate in car parks, on narrow roads, in slow-speed urban environments. 10.8 meters is a notably tight figure for a car of the Supra's size and performance orientation. Sports cars with long wheelbases and wide tracks do not always prioritize low-speed agility, and some accept a larger turning circle as a consequence of their dimensions. The Supra's engineers paid enough attention to this characteristic that the car remained genuinely manageable at low speeds, in real-world conditions, rather than being a car that was only at home when the road opened up. It is a small quality-of-life detail, but it is a telling one. Another indication that the people who built this car thought carefully about every aspect of how it would be lived with, not just how it would perform when pushed. Air and grip and geometry. The invisible architecture that surrounds every moment of driving. The Supra managed all of it with the same quiet thoroughness that defined every other aspect of its engineering. The wing pushed it down. The resonance chamber kept it quiet. The wishbones kept it level. The rotors kept it controllable. And all of that existed to serve the driver, to give them a car they could trust completely. Which brings us quite naturally to where that driver sat. Inside, it was a different kind of story entirely. A story of focus and of purpose, and of a cockpit designed with one thing clearly in mind. We have spent a great deal of time outside the car, under the hood, beneath the body, in the air moving around the bodywork at speed. Now we come inside. We close the door, settle into the seat, and look forward. This segment is about the cockpit of the MK4 Supra, the space the driver occupied, the surfaces they touched, the instruments they read, and the details that made the interior feel like something designed with a clear and consistent purpose. It is a quieter kind of engineering story than the engine or the aerodynamics, but no less considered. Let everything slow down a little more, and let's take a careful look around. The dashboard of the MK4 Supra wraps around the driver. This is a design approach, sometimes called a driver-oriented cockpit, in which the instrument panel and center console are not arranged as a flat, symmetrical surface facing straight ahead, but are instead curved and angled so that the driver sits at the focal point of everything around them. In a car designed for performance, this matters. When the driver needs information, speed, engine revs, oil temperature, boost pressure, that information should be immediately visible without requiring them to turn their head or search across a wide expanse of dashboard. In the Supra, the instrument sat directly in the driver's sightline, close and clear, framed by a dashboard that curved inward on both sides, as if to quietly acknowledge that this was, above all else, a driver's car. Complementing the wrapped dashboard, the controls within the cabin were angled toward the driver rather than positioned neutrally between driver and passenger. The switches, the ventilation controls, the audio system, all of it oriented slightly toward the left seat, the seat that mattered most in this car. It is a subtle thing, and many drivers would experience it without ever consciously registering it. But the cumulative effect of the dashboard that curves around you and controls that face you is a sense of being held by the car rather than simply sitting in it. The Supra's cabin communicated the same seriousness of purpose that its engine and suspension did, a quiet insistence that everything here was arranged in service of one person, in one seat, doing one thing. The seats in the MK4 Supra were narrow, and they were heavily bolstered. Bolsters are the raised sections on either side of the seat cushion and backrest, the parts that brace the occupant during cornering, preventing them from sliding laterally when the car changes direction quickly. In a car capable of nearly a full G of lateral acceleration, effective bolstering is not a cosmetic feature. It is a functional one. The driver, who is well supported by their seat, can feel the car's movements through their body, can sense the onset of understeer or oversteer before it becomes a problem, and can apply steering and throttle corrections with precision because their body is stable and their hands and feet are free to move without compensating for unwanted lateral movement. The narrow, heavily bolstered seats of the Supra were part of its handling package, as much as the double wishbone suspension beneath them. The pedal placement in the cockpit was arranged to facilitate a driving technique known as heel and toe. Heel and toe is a method of simultaneously braking and downshifting. The driver uses the ball of their right foot to press the brake pedal, while rotating the heel or outside edge of the same foot to blip the throttle, matching engine revs to the lower gear being selected. It is a technique that keeps the car balanced and the drivetrain smooth during hard deceleration into corners, and it requires the brake and throttle pedals to be close enough in height and lateral position to be operated simultaneously by a single foot. Not all cars are designed with this in mind. The Supra was. The pedal placement was deliberate, and it gave drivers who knew the technique the physical means to use it without modification or awkward adaptation. another quiet acknowledgement built into the architecture of the car. That performance driving was understood and accommodated here. The instrument cluster favored simple analog gauges. In an era when digital displays were becoming increasingly fashionable in automotive interiors, flickering numbers and segmented readouts that aimed to convey a sense of technological modernity, Toyota chose to equip the Supra with traditional round dials. A large tachometer and speedometer sat at the center of the cluster, supplemented by smaller gauges for oil temperature, water temperature, fuel level, and turbo boost pressure in the turbocharged models. Analog gauges are read differently to digital ones. The position of a needle conveys information in a way that is processed peripherally, almost unconsciously. The driver does not need to read a number. They simply sense whether the needle is where it should be. In a car being driven hard, that peripheral readability is valuable. The gauges told the driver what they needed to know, without asking them to look away from the road to interpret a number. For the interior trim, buyers could choose between cloth and leather upholstery. The cloth option was the base specification, practical, breathable, and well suited to everyday use. The leather option added a layer of refinement that made the Supra feel more deliberately luxurious, more like a grand tourer than a pure sports car. Both options were executed with the quality expected of a Toyota product in this price range. The seats wore their upholstery neatly, the stitching was consistent, and the materials held up over time in the way that well-made interiors do. The choice between cloth and leather was one of the few areas in which the Supra invited its buyers to express a preference, to define in a small way whether they wanted a car that felt like a focused driver's machine, or one that also offered a degree of daily comfort and visual warmth. Audio was available at a high level for buyers who wanted it. A 7-speaker sound system with a dedicated subwoofer could be specified, offering a level of audio quality that was genuinely impressive by the standards of early 1990s factory-fitted car audio. The subwoofer, mounted in the rear cargo area made available by the liftback body, provided bass extension that smaller speaker systems could not replicate. For a car that would spend time on long motorway journeys as well as winding roads, the quality of the audio system mattered. It was part of what made the Supra livable as well as capable. 7 speakers in a 2-door sports car represents a thoughtful distribution of sound across the cabin, ensuring that music reached the driver and passenger with balance and clarity, rather than simply emanating from a single point. The radio unit fitted to the Supra used a double DIN mounting format. DIN is a standardized measurement for car audio head units. A single DIN unit occupies a space 50 mm tall and 180 mm wide, and a double DIN unit is exactly twice the height. The double DIN format became the standard mounting size for higher specification head units as the technology in them grew more complex and the displays larger. By fitting a double DIN unit from the factory, Toyota ensured that owners who wished to replace or upgrade their audio head unit could do so straightforwardly, using any of the widely available aftermarket units built to the same standard. It was a small but practical detail that contributed to the Supra's longevity as a car that could be maintained and personalized over many years of ownership without running into unnecessary compatibility obstacles. The MK4 Supra was offered with optional dual front airbags, one for the driver and one for the passenger. Airbags were not universal equipment in the early 1990s, particularly outside the United States, where regulatory pressure had been pushing their adoption more aggressively than in other markets. Offering dual front airbags as an option placed the Supra at the more safety-conscious end of the sports car spectrum. In an era when some manufacturers still regarded such systems as unnecessary weight or complexity in a performance context, Toyota's decision to make them available reflected the company's broader approach to the A80, a car that took performance seriously but did not treat safety as an afterthought. More significantly, the MK4 Supra was among the first Toyota models to offer a passenger-side airbag as a standard fitment rather than an optional extra. Most manufacturers who had begun fitting driver airbags in this period were doing so on the driver's side only, treating the passenger airbag as a secondary consideration, including it as standard, not as an upsell, not as a cost option, but as part of the car's base specification, was a meaningful distinction. It signaled a philosophy in which the safety of the person in the left seat was not considered less important than the safety of the person in the right seat, regardless of whether or not a regulation required it. In a car built with this level of attention to every other detail, that consistency of care is, in retrospect, entirely expected. The cockpit of the MK4 Supra is a room that was designed to answer a single question: what does the driver need? It answered with a wrapped dashboard, angled controls, bolstered seats, thoughtful pedal placement, clear analog gauges, considered audio, and genuine safety provision. Nothing in that list is dramatic. None of it accelerates the car or improves its lap time, but all of it shapes the experience of being inside it. The quiet, sustained impression that the car was built by a people who had imagined sitting in it and had arranged everything accordingly. And when you stepped out of that cockpit, closed the door, and walked around the outside, what you saw depended very much on where in the world you were. Because depending on where you lived, your Supra might have looked very different indeed. The MK4 Supra was a single car with a single name, but it was not one thing. Depending on the country where it was sold, the year it was built, and the specification level a buyer chose, the car could differ in meaningful ways. In trim level, in body style, in engine configuration, in the details of how it was equipped. This segment is about the many forms the A80 took across its production life. and about the rarer variants that existed at the edges of that production. The special editions, the limited runs, the one-offs that most people never saw. Let the numbers and the names settle quietly as we move through them. In Japan, where the Supra was built, and where it was sold in its most complete range of specifications, the trim hierarchy consisted of 4 main variants: the SS, the RZ, the RZS, and the GZ. Each designation indicated a different level of specification and a different engine configuration. The SZ sat at the base of the range, fitted with the naturally aspirated 2JZGE. The RZ and RZS were the turbocharged manual options, the RZ being the more accessible of the two, and the RZS offering a higher level of standard equipment. The GZ was the automatic turbocharged variant, aimed at buyers who wanted the full performance of the twin turbocharged engine without the engagement of a manual gearbox. Together, these 4 trim levels allowed Toyota to serve a range of buyers within the Supra model line, from those who wanted the car's shape and platform with a more relaxed engine, to those who wanted every performance advantage the factory could offer. In the United States, the Supra had a shorter and more concentrated presence. American sales began with what is commonly referred to as the 1993.5 model year, a mid-year introduction that placed the car in dealerships partway through the 1993 calendar year and continued through to 1998, 5.5 model years. It is a brief window by the standards of a car that remained in production elsewhere until 2002, and it reflects the combination of factors that made the American market difficult for the Supra during that period. The price was high, the dollar was unfavorable relative to the yen for much of the 1990s, and the market for expensive Japanese sports cars in the United States was never as deep as Toyota might have hoped. The cars that did reach American buyers were well received, but there were never very many of them. In total, across all markets and all years of production, worldwide output of the MK4 Supra is estimated at approximately 45,000 units. That is a small number for a car produced over 9 years by one of the world's largest automotive manufacturers. For comparison, Toyota produced that many Camrys in a matter of weeks during the same era. The Supra was always a low-volume car, a flagship, a statement, a machine that existed at the edge of what the company could do, rather than at the center of what it actually sold. Those 45,000 cars are now spread across the world, aging at different rates, preserved with different levels of care, and valued in ways that have changed dramatically since the last one left the factory. Within the already modest American sales total, the numbers for individual years are striking in their smallness. In 1994, the first full model year of American sales, only 3,488 Supras were sold in the United States. 3,488 cars. spread across a country of nearly 260 million people at the time, that figure represents a car that most Americans never encountered in a showroom, never saw on a road, and never had the opportunity to consider as a purchase. The Supra existed in American automotive culture more as a presence in magazines and on racetracks than as a car that appeared in daily life. Its rarity was not manufactured. It was simply a consequence of how few were made and how vast the country was. In Europe, the numbers were smaller still. Left-hand drive European specification cars totaled approximately 1,678 units across the entire production run. That figure encompasses every country on the continental European mainland that received the car: Germany, France, Switzerland, the Netherlands, and others combined. Just over 1,600 cars to serve a market of hundreds of millions of people across dozens of countries. The European Supra was, from a production standpoint, almost a curiosity, present enough to be officially sold and supported, but rare enough that encountering one on a public road was a genuinely uncommon experience for anyone who did not actively seek them out. The right-hand drive European specification cars were rarer still, produced for markets such as the United Kingdom and other right-hand drive European territories. Only approximately 673 of these cars were built in total. 673. It is a figure that sits somewhere between a limited edition and a standard production run. Too many to be truly exclusive in the manner of a purpose-built special, but few enough that every surviving example occupies a meaningful place in the record of what was made. Owners of right-hand drive European Supras possess something genuinely uncommon, and the care with which many of them maintain and preserve their cars reflects an awareness of that scarcity. Across all markets, the Supra was available in two distinct body configurations. The fixed roof hardtop was the standard form, a rigid, welded steel body with a conventional rear window, offering the structural integrity and cabin refinement that came from having no removable sections. The alternative was the aero top, a Targa-style body in which the roof panel above the occupants could be removed and stored, opening the car to the sky. The aerotop panels were glass, tinted, treated glass that could be slid out and stowed in a dedicated bag, typically placed in the boot alongside whatever else the owner was carrying. With the panels removed, the Supra offered a degree of open-air motoring without the structural compromises of a traditional convertible. With them in place, it looked almost identical to the hardtop. The choice between the two body styles was one of the more personal decisions a Supra buyer could make: practical weather protection or occasional sky on a clear day, when the road was empty and there was nowhere particular to be. In 1997, the A80 received a mild facelift. The updates were modest rather than transformative, the kind of mid-cycle refresh that a manufacturer applies to keep a car feeling current without rebuilding it from the ground up. changes to the exterior were subtle, involving revised details rather than reshaped panels. The introduction of VVT1 on the turbocharged engine, bringing the torque increase to 338 pound-feet discussed in an earlier segment, was among the most significant changes underneath the surface. The 1997 facelift cars are sometimes distinguished by enthusiasts from the pre-facelift models, but they share the same fundamental character, the same platform, and the same essential identity. They are the same car, brought gently up to date. In certain markets, Toyota marked a production milestone with special anniversary editions. The 15th anniversary of the Supra nameplate, the original Supra having debuted in 1978, was acknowledged with limited-run models offered in select regions. These anniversary editions typically featured specific color options, unique badging, and in some cases enhanced standard equipment, distinguishing them visually and specification-wise from the regular production cars available alongside them. Anniversary editions in the automotive world occupy an interesting space. They are seldom mechanically distinguished from the cars they are based on, but they carry a commemorative significance that makes them appealing to collectors and to buyers who wanted something that acknowledged the car's history rather than simply being another example of it. At the very edge of what could reasonably be considered a production Supra sits the TRD 3000 GT, TRD, Toyota Racing Development, was Toyota's in-house performance and motorsport division, and the 3000 GT was their interpretation of what the A80 could become when the constraints of volume production were removed. The TRD 3000 GT featured a wide-body kit that extended the car's track and altered its proportions significantly, along with suspension and powertrain modifications intended for serious performance use. Only approximately 35 complete cars were built. 35. In a production run of 45,000, that figure is so small as to border on the theoretical, a whisper of a variant, present in the historical record, but absent from almost every real-world collection. Cars of this rarity tend to surface rarely and command significant attention when they do. The TRD 3000 GT is the Supra at its most extreme from the factory. The furthest the car's creators were willing to take it within an official program. 45,000 cars, spread across Japan, the United States, Europe, and other markets around the world. Available in 2 body styles, multiple trim levels, 2 engine configurations, and 2 gearbox options. Occasionally marked with anniversary editions, and at the outer boundary of it all, 35 wide-bodied TRD machines that exist somewhere between a production car and a racing one. The MK4 Supra is a small family of related objects, each slightly different, each carrying the same name and the same fundamental engineering, and each belonging to a particular place and time. Where you were and when you bought it determined which one you got. And while the outside of the car varied depending on market and specification, the inside, the experience of actually driving it, told a story that needed no translation. We have already established that the MK4 Supra was not a common car. 45,000 units across 9 years of global production is a modest figure by any measure. And within that total, certain variants and specifications exist in numbers so small that they occupy a different category entirely. Not rare in the way that a limited edition sports car is deliberately rare, but rare in the way that circumstances, market forces, and the quiet accumulation of time produce. This segment is about those numbers, about the specifications that were made in quantities so small that finding one today requires patience, money, and a certain willingness to wait. 5 facts, but each one worth sitting with for a while. We met the TRD 3000 GT briefly in the previous segment, the wide-body variant produced by Toyota Racing Development in an edition of approximately 35 complete cars. Now we can look at it a little more closely, because the widening it received was not simply a visual exercise. The TRD 3000 GT's bodywork extended the car's track by 60 mm at the front axle and 50 mm at the rear. Those are substantial increases. Track width, the distance between the left and right wheels on the same axle, has a direct effect on a car's cornering behavior. A wider track lowers the car's roll center, reduces body roll during cornering, and increases the lateral stability of the vehicle at high speeds. The 60 mm front and 50 mm rear additions were not arbitrary figures chosen for visual drama. They were the result of TRD's engineering decisions about what the car needed to perform at the level they were targeting. The wider bodywork also accommodated larger wheels and tires, giving the car more contact patch, more grip, and a stance that made the standard Supra look almost understated beside it. 35 cars, each one carrying those additional 60 mm at the front and 50 at the rear, each one a statement of what Toyota's own performance division considered the A80's ultimate form. Among the colors available for the MK4 Supra across its production life, one has become particularly sought after in recent years: Imperial Jade Mica. It is a deep, complex green, shifting in quality depending on the light and the angle from which it is observed. In direct sunlight, it reads as a rich, saturated jade. In shadow, it deepens towards something closer to forest, with a metallic quality that moves across the surface as the car does. Colors like this, with depth and complexity rather than simple saturation, tend to age well. They do not tire the eye. They reward extended attention in a way that brighter or more straightforward colors sometimes do not. The reason Imperial Jade Mica has attracted such dedicated interest among collectors is not only its visual quality though, it is its scarcity. Approximately 102 MK4 Supras were produced in Imperial Jade Mica across the entire production run. 102 cars in all markets over all model years. Finding a surviving example in good, unmodified condition, with its original paint intact, is a genuinely difficult undertaking. Each one that surfaces draws attention that reflects exactly how few of them there are. If 102 units of a paint color sounds rare, the next figure requires a different frame of reference entirely. The combination of royal sapphire pearl paint and a 6-speed manual gearbox, one of the most visually and mechanically desirable configurations a buyer could have specified, resulted in approximately 31 cars being produced worldwide. 31. Royal sapphire pearl is a deep, dark blue with a lustrous quality that photographs well and looks extraordinary in person, particularly on a car with the Supra's proportions and the aggressive presence of the large rear wing. Pairing that color with the Getrag V160 6-speed. The transmission that, as we have already discussed, is now itself extremely rare and expensive, produces a car that combines two scarcities into one. The number of surviving Royal Sapphire Pearl 6-speed Supras in the world today, accounting for accidents, modifications, repaints, and the ordinary attrition of decades, is almost certainly lower than 31, possibly much lower. Each remaining example is, by almost any definition, irreplaceable. And then there is this, the 1995 model year Alpine Silver 6-speed twin-turbo Supra. Research into production records suggests that this particular combination, Alpine Silver paint, manual gearbox, turbocharged engine, 1995 model year, may have resulted in as few as 2 cars being produced. 2. It is a number that is almost difficult to take seriously as a production figure, and yet the documentation behind it is the result of careful, methodical research into the surviving records of what was actually built. If the figure is accurate, and the evidence suggests it is, then there are at most 2 Alpine Silver 1995 manual turbo Supras in existence, and very possibly only one. The story of how such combinations come to exist in such small numbers is not dramatic. It is simply the arithmetic of a low-volume car produced in many colors, across many model years for many different markets, with each possible combination of color, year, engine, and gearbox generating its own tiny production total. Some of those totals are in the hundreds, some are in the tens, and some, it turns out, are in the ones. Setting aside paint colors and production numbers for a moment, the cars sold outside of Japan carried physical differences from the Japanese domestic market specification that went beyond labeling or documentation. Export models, those built for the United States, Europe, and other non-Japanese markets, received different front and rear bumpers from their JDM counterparts. The styling was adjusted to meet the specific pedestrian safety and impact regulations of different markets, and in some cases to accommodate the different lighting requirements of countries with varying road rules. Side marker lights, small amber or red lamps set into the sides of the body near the front and rear, were fitted to export cars in configurations that differed from the JDM standard, again reflecting local regulatory requirements. To someone who knows the car well, these differences are visible and identifiable. The bumper profiles, the marker positions, the subtle differences in how the front and rear of the car were finished. They are the kind of details that allow an informed observer to determine, at a glance, not only which generation of Supra they are looking at, but roughly which market it was built for. The Supra was one car with one name, but it wore slightly different faces depending on where in the world it was going. There is something quietly absorbing about the arithmetic of rare cars. It is not the excitement of a race or the urgency of a deadline. It is more like the satisfaction of a very precise count. 102 jade green cars somewhere in the world, 31 sapphire blue 6-speeds, possibly 2 Alpine Silver 1995 manual turbos, 35 wide-bodied TRD machines. These numbers ask nothing of you. They do not require a response or a decision. They simply exist, small, specific, and somehow calming in their precision. Each number represents a set of real objects that are out there somewhere, in garages and collections and storage facilities, aging at different rates, maintained with different levels of care, waiting for whatever comes next in their long lives. The world contains these cars. Most of us will never see one. That is, in its own quiet way, a perfectly comfortable thought to rest with. And yet, despite everything, despite the small production numbers, despite the rarity, despite the prices that surviving examples now command, the MK4 Supra is not simply a collector's object. It is not a car that exists only in climate-controlled storage, brought out occasionally for shows and then returned to darkness. It is something more than that. Something that persisted in a way that goes well beyond its production numbers, well beyond the handful of Alpine silver cars or jade green examples or wide-body TRDs. Because despite everything, it became something else entirely. Everything we have discussed so far has been, in its own way, a story of success. The engineering succeeded, the engine succeeded, the chassis, the aerodynamics, the gearbox, the cockpit. All of it came together into a car that was, by almost every technical and experiential measure, exactly what Toyota had set out to build in those first meetings in February of 1989. But success in engineering and success in business are different things, and they do not always arrive together. This segment is about the gap between them, about what the MK4 Supra cost, who it was competing against, and what happened when the numbers came in. It is a quieter story than the ones that came before it. Let it settle at its own pace. A well-equipped MK4 Supra in the 1990s carried a price tag of between $40,000 and $50,000 in the United States. The base turbocharged car began at the lower end of that range, and options: the leather interior, the premium audio system, the Targa roof, additional packages, pushed the price toward and sometimes beyond the upper boundary. $40,000 to $50,000 was, by the standards of the early to mid-1990s, a substantial sum of money for any car, let alone one produced by a Japanese manufacturer that many American buyers still associated primarily with practical, affordable transportation. Toyota had built an extraordinary machine, but they had built it at a price that placed it beyond the reach of most buyers who might otherwise have considered it, and within the reach of buyers who had a great many other options available to them. Adjusted for inflation, that $40,000 to $50,000 purchase price translates to over $92,000 in today's money. $92,000. Stated plainly, in present-day terms, the MK4 Supra was a $92,000 car. That figure reframes the commercial challenge Toyota faced entirely. At that price, the Supra was not simply an expensive sports car. It was a luxury sports car, competing for a type of buyer who had very specific expectations about what their money should provide. Buyers spending $92,000 on a car today expect a level of brand prestige, cabin refinement, and dealer experience that is difficult to separate from the hardware itself. In the 1990s, spending that equivalent sum on any car carried similar expectations, and the Supra, extraordinary as it was mechanically, was asking buyers to invest at a level that its badge and its showroom presence did not always fully support. At that price point, the Supra was in direct competition with two of the most established and respected names in performance motoring. The Chevrolet Corvette, America's sports car, produced in enormous numbers, with decades of cultural presence and a fiercely loyal domestic buyer base, occupied the same approximate price territory, and the Porsche 911, the German rear-engine sports car, with an unbroken lineage stretching back to the 1960s and a brand identity that carried enormous weight in the minds of performance car buyers worldwide, sat in the same competitive set. Against the Corvette, the Supra had to argue for itself against a car that was cheaper, faster in some configurations, and deeply embedded in American automotive culture. Against the Porsche, it had to argue against the heritage, a brand story, and a prestige that Toyota, for all its engineering excellence, simply could not match on the same terms. The Supra was technically the equal of both, and in certain respects, their superior. But the market did not always reward technical excellence in proportion to its merit. The result of all of this, the high price, the difficult competitive landscape, the modest production numbers, was that the MK4 became the least commercially successful generation of the Supra across the entire nameplate's history. The A40, the A60, and the A70 had each found their buyers in reasonable numbers. They had been priced accessibly enough and positioned broadly enough to sell with a degree of ease that reflected a healthy relationship between the car's cost and its appeal. The A80 found no such equilibrium. Its ambition had raised its price, and its price had narrowed its audience, and its narrowed audience had not been deep enough to sustain the volumes Toyota needed to justify its continued production. The most capable Supra ever built was, commercially, the one that struggled most. Pause here. Allow a moment of quiet before continuing. There is something worth sitting with in that fact. The engineers who had started work in February of 1989 had spent years reducing weight, selecting materials, specifying gearboxes, tuning suspension geometry, and testing prototypes on closed roads. They had solved problems that most manufacturers had not even thought to ask about. The resonance chamber in the spoiler, the lighter head bolts, the 7 main bearings, the ceramic turbo shafts, the magnesium steering wheel frame. They had produced a car that would, 30 years later, still be regarded as one of the finest sports cars ever built. And in the years it was actually on sale, most people did not buy it. Not because it was not good enough, because it cost too much, at a time when the currency exchange was unfavorable, in a market where its name carried less weight than the names it was competing against. The engineering was irrelevant to that calculation. The market did not measure what the engineers had made. It measured the price tag and the badge. Weak sales throughout the mid to late 1990s led Toyota to make the decision to end production in 2002. By that point, the Supra had been on sale for 9 years, with only a single mild facelift and no fundamental reinvention. The development costs had long since been absorbed. The car was aging, even if it was aging well, and the case for investing in a complete redesign, for building a 5th-generation Supra that could compete in a market that had grown even more demanding, could not be made on the basis of how the 4th generation had sold. So production ended. Quietly and without ceremony, the last MK4 Supras rolled off the line in 2002, and Toyota turned its attention elsewhere. There was no announcement of a replacement, no promised future model, just a silence where the car had been. It would be more than 15 years before the Supra name appeared on a new production car. And in those 15 years of absence, something unexpected happened to the commercial failure that the A80 had been. The market that had rejected it at $40,000 to $50,000 began, slowly and then very quickly, to reconsider. The engineers had been right all along. The car had always been worth what they asked for it, and then some. It had simply taken time, and distance, and rarity, and the long perspective that only years can provide, for the rest of the world to catch up with what the people who built it had known from the beginning. The commercial failure became, in the fullness of time, one of the most desirable used cars in the world. And that is a story we will come to in its own time. We left the previous segment in a quiet place. Production had ended in 2002. The last cars had been built. Toyota had moved on. And the MK4 Supra, the commercial disappointment, the underappreciated masterpiece, sat in the used car market, aging, losing value in the ordinary way that cars do when they are simply old and no longer new. It might have continued that way. Many great cars do. They recede into the background, known to specialists and enthusiasts, but invisible to the broader world. Their significance understood only by the people who already understood it. The Supra did not do that. Instead, something happened. Something that no one at Toyota's design meetings in 1989 could have planned for, or predicted, or engineered. The car became famous. Not in the way that well-reviewed cars become famous. In a different way entirely. This segment is about how that happened. In the summer of 2001, a film was released in cinemas around the world. It was called The Fast and the Furious, and it was built around a simple premise. Illegal street racing in Los Angeles, fast cars, and a cast of characters whose loyalty to one another was expressed through the cars they drove and the risks they took together. It was not a film made for automotive critics. It was not attempting to document the real world of performance driving. It was entertainment, directed at a wide audience, made with a kind of energy and visual confidence that translated well to a large screen and a loud sound system. And somewhere near the center of it, appearing at a moment that the audience remembered long after the credits rolled, was a Supra, a 1994 model, painted a bright, vivid orange that left absolutely no doubt about which car the camera was meant to be looking at. The orange Supra in The Fast and the Furious did not simply appear in the background of a scene. It was a character in its own right, introduced deliberately, assembled on screen from parts, driven with intent, and positioned at the climax of the film's most significant racing sequence. In that sequence, the Supra is matched against a Ferrari 355 on a public highway. The Ferrari, a car that cost several times as much as the Supra, that carried one of the most revered names in automotive history, and that represented everything that expensive European performance machinery stood for, was beaten. The Supra won. The image of a modified Japanese sports car from the early 1990s, built on a budget, pulling away from a Ferrari on a straight road, landed in the minds of an enormous audience and settled there. It gave the car a story, a clear, simple, compelling story, that the Supra was something that could stand alongside the best in the world and not be found wanting. That it was, in the language that the film's audience would go on to use for years afterward, a giant killer. The film did not create that quality in the car. The quality had always been there, waiting in the iron block and the 7 main bearings and the overbuilt bottom end. The film simply pointed at it in a language that everyone could understand, and said, "Look at this." The timing of the film's release coincided with the growing reach of another medium that was shaping how a generation of young people thought about cars. The Gran Turismo series of video games released on PlayStation consoles from 1997 onward had introduced an enormous global audience to a style of automotive experience that had never previously been accessible to most people. Gran Turismo was not a racing game in the traditional sense. It was a simulation, painstakingly detailed in its handling models, obsessive about the accuracy of its car specifications, and structured around the idea of earning and owning and driving cars that most of its players would never be able to afford in the real world. The MK4 Supra was present in Gran Turismo. Players could acquire it, tune it, race it, and spend hours driving it across circuits and mountain roads that existed only as software. For a significant number of people who grew up with those games, the Supra was not an abstract automotive legend. It was a car they had driven, in the only way available to them, thousands of times. They knew its shape from the inside. They knew how it felt, or at least how the game represented how it felt, to push it to its limits. The Need for Speed series added another layer to this, placing the Supra in a different visual and cultural context, but reinforcing the same essential message. This car is something special. This car belongs in the company of the fastest and most desirable machines in the world. A generation grew up dreaming about it. That sentence is plain and simple, and it deserves to sit plainly for a moment before being elaborated upon. The people who were children and teenagers in the late 1990s and early 2000s, who played Gran Turismo on Saturday mornings, who went to see The Fast and the Furious in cinemas, or watched it on DVD with friends, who printed photographs of orange Supras from early internet forums and kept them in school folders or stuck them to bedroom walls. Those people grew up. They got jobs. They saved money. And when they had enough, a significant number of them went looking for the car they had been thinking about since they were 12 or 13 years old. The used car market for the MK4 Supra, which had been modest and unremarkable through most of the 2000s, began to shift. Interest gathered, prices moved. And then, over the course of the 2000s, they moved again, more dramatically, more quickly, until a car that Toyota had struggled to sell for $40,000 to $50,000 in the 1990s was commanding $80,000, $100,000, $150,000 and beyond on the used market. The commercial failure had become a collector's car. The car that too few people had wanted at the time had become a car that too many people wanted now, with too few examples available to satisfy them. Tuning culture embraced the Supra globally, and it did so in a way that extended the car's presence beyond the small world of original owner collectors into something much wider. From Japan, where the culture of modifying and racing the A80 had been established almost from the moment the car went on sale, to the United States, to Europe, to Australia, to countries where right-hand drive JDM imports found new homes after their Japanese registrations had lapsed. The Supra became a platform, a starting point, a car that the modification community understood, trusted, and continued to invest in long after the factory had stopped building new ones. The 2JZ engine, as we have already discussed in detail, was central to this. Its capacity for enormous power on stock internals made it the engine of choice for builders who wanted results without the cost and complexity of extensive bottom-end work. But the culture that surrounded it went beyond pure performance. The Supra attracted builders who cared about aesthetics, about sound, about the experience of driving a modified car on an empty road at night. It attracted people who wanted to understand the car deeply, who learned to service their own engines, to rebuild their own gearboxes, to weld their own exhaust systems. It built a community of knowledge that is still active and still growing today, decades after the last factory car was completed. What the Fast and the Furious, Gran Turismo, Need for Speed, and global tuning culture had in common was this: they all pointed at the same car and agreed that it mattered. They reached different audiences through different channels at different moments. But the message was consistent. The MK4 Supra was not an ordinary car. It was something that deserved attention and respect and aspiration. And when enough different sources are saying the same thing to enough different people over enough years, the cultural weight of that agreement becomes something that no amount of modest sales figures or discontinued production runs can overcome. The engineers who had struggled to sell the car at $40,000 to $50,000 had, without knowing it, built something that would be worth far more than that to far more people than had ever walked into a Toyota showroom in the 1990s. They had built it for a market that did not yet exist, and that market, when it finally arrived, found the car exactly where they had left it, in garages and on streets, in video games and on cinema screens, waiting, as it had always been waiting, to be properly appreciated. We are near the end now. Over the course of this video, we have moved through the entire life of a single car, from its first design meetings in 1989 to the moment production ended in 2002, and then through everything that happened afterward, in the years and decades when the car was no longer being made, but was, in many ways, still becoming. This final segment is about where that journey ends, or rather, where it has arrived so far, because the story of the MK4 Supra is not finished. It is still being written, slowly and quietly, in workshops and on road courses, and in the careful records kept by people who have decided that this particular machine is worth preserving. Let's bring it home gently. Clean, unmodified, well-maintained examples of the MK4 Supra now sell for over $100,000. That figure would have been unimaginable to the buyers who walked into Toyota dealerships in 1993 and balked at the $40,000 to $50,000 asking price. It would have been equally unimaginable to Toyota's accountants. Watching the sales numbers come in through the mid-1990s and concluding that the car was not finding its market. But the market, it turned out, was not ready in 1993. It was being formed in bedrooms and living rooms and arcade halls and cinema seats over the decade that followed. And by the time that market was ready, by the time the children who had grown up dreaming about the car were old enough and solvent enough to act on those dreams, the cars were already rare, already aging, already possessed of the particular weight that time and scarcity confer on objects. $100,000 is not an unreasonable price for something irreplaceable. It is simply what irreplaceable things cost. At the upper end of the market, the most desirable examples command considerably more than that. Low-mileage twin-turbocharged Supras with a Getrag V160 six-speed gearbox, the combination that represents the car at its most complete and most capable, have reached prices in the mid-six figures at auction and in private sales. Mid-six figures. $300,000, $400,000 for a production sports car built on a Toyota assembly line in the early 1990s. Each element of that combination contributes to the value. The low mileage, which is increasingly rare as the cars age and accumulate use. The twin-turbo engine, which carries more power and more legend than the naturally aspirated alternative, and the V160 gearbox, itself now scarce and expensive as a standalone component. When those three things come together in a car that has been carefully kept and honestly documented, the result is an object that serious collectors treat with the same consideration they would give to a rare piece of art or an important historical document, because that is in a real sense what it has become. Among collectors and the broader community of automotive enthusiasts, unmodified MK4 Supras are now classified as modern classics. The term has a specific meaning in the collector car world. It refers to vehicles that are recent enough to have been driven by people still living, that retain a connection to the present moment through living memory and continuous use, but that are old enough and significant enough to have acquired genuine historical standing. A modern classic is not simply an old car. It is a car that has been judged by the slow and unsentimental process of time and market consensus to have mattered, to have been good enough, interesting enough, and distinctive enough to deserve preservation and study, rather than simply use and disposal. The MK4 Supra has earned that classification without controversy. There is no serious debate about whether it belongs there. The question is not whether it is a modern classic, but how significant a one. Much of the value that has accumulated around the car, and much of the desire that drives buyers to pay those extraordinary prices, is rooted in nostalgia. Nostalgia is not a simple emotion. It is not merely sentiment or fondness for the past. It is the specific weight of a formative experience, the way that certain objects or places or sounds carry within them the entirety of a period of life that cannot be returned to. For a generation that grew up with the MK4 Supra as a presence, in games, in films, in magazines, in the dreams of what a fast car could be, the car is not simply a machine. It is a vessel. It carries something of childhood in it, something of aspiration and possibility, and the particular quality of wanting things you cannot yet have. Buying the car, for many of its current owners, is an act that reaches across years toward a younger self who had a poster on a wall somewhere. The engineering justifies the price. The nostalgia explains it. The 2JZ engine has, through all of this, become an icon that extends far beyond the boundaries of Toyota, far beyond the Supra, far beyond the Japanese domestic market, or the American import scene, or any single community that claims it. It is simply known. Mechanics who have never worked on a Supra know the name. Engineers who build engines for different manufacturers have studied its architecture. Tuners who specialize in entirely different platforms reference it as a benchmark when discussing what an overbuilt production engine looks like. The 2JZ became a whole cultural shorthand, a way of saying, here is an engine that was built with more integrity than the task required, and that integrity paid dividends over decades that no one fully predicted. It is a lesson in engineering philosophy as much as it is a specific piece of machinery. Build it stronger than you need to. The surplus will find a use. In direct comparisons with its contemporaries, the Nissan 300ZX, the Mitsubishi 3000 GT, other Japanese sports cars that occupied the same performance tier in the early 1990s, the 2JZ's durability is still regularly cited by tuners and builders as the decisive advantage. The 300ZX and the 3000 GT were fine cars with capable engines, and they each had their devoted followings. But when the conversation turns to which platform a serious builder would choose for a high-power project requiring both capability and longevity, the 2JZ wins that conversation with notable consistency. Not always unanimously, opinions vary, and loyalties run deep. But the weight of accumulated experience, the sheer volume of documented builds and recorded results, tends to resolve the discussion in the 2JZ's favor. It is the engine that the evidence keeps returning to. The MK4 Supra has never fully left competitive motorsport. Decades after production ended, examples continue to appear at road racing events, on tracks and in time attack competitions, and in the kinds of grassroots motorsport where participants build and maintain their own cars, and race them because they love doing it, rather than because any prize money justifies the effort. The cars that compete today are often heavily modified, carrying components that Toyota never imagined fitting, but they run under the same body, over the same platform, with the same basic engine architecture that rolled out of the factory in Tahara. The car is still being raced. It is still being developed. The engineers who chose the iron block and the 7 main bearings made a decision whose consequences are still unfolding. Among the quieter achievements of the 2JZ and the platform it powers, one deserves particular mention. There are documented examples of MK4 Supras that have surpassed 500,000 miles on their original drivetrains. The original engine, the original gearbox, without a complete rebuild of either. 500,000 miles. That figure requires a moment of consideration. An engine that started its life on a production line in the early 1990s that has been turning continuously through 3 decades of use, that has survived temperature cycles and load cycles and the ordinary violence of combustion hundreds of millions of times, and is still functioning, still sealing, still turning, still delivering power to wheels and moving a car down a road. It is, by any reasonable measure, a remarkable demonstration of what careful engineering and consistent maintenance can produce. Together, the engineers built it to last. Some of them may not have known quite how long. Once overlooked, now revered worldwide. Those 5 words carry the entire arc of the car's story. The commercial struggle, the quiet years, the cultural rediscovery, the rising values, the community that formed around it, the respect that accumulated slowly, and then all at once. There are not many objects in any field that travel that particular path, from failure to legend, with the completeness and the clarity that the MK4 Supra has managed. And the reason it made that journey, rather than simply fading away as most overlooked things do, is embedded in the car itself. The quality was always there. The engineering had always justified the regard. The world simply needed time to arrive at the conclusion that the engineers had started from. The MK4 Toyota Supra became a legend not by accident, but by over-engineering. That is the simplest and most accurate summary of everything we have covered tonight. The 7 main bearings in an engine that only needed 5. The magnesium steering wheel frame, the lighter head bolts, the resonance chamber in the spoiler, the 51 to 49 weight distribution, the V160 gearbox, built to tolerances that have outlasted the century in which it was designed. None of these things made headlines. None of them appeared prominently in brochures. They were simply the decisions of people who had been given the task of building the best car they could, and who took that task seriously enough to keep asking whether something could be done better, long after a reasonable person would have stopped asking. The result of all that asking, all those meetings, all those prototype miles, all those material selections and weight calculations and geometry decisions, is a car that is still being driven, still being raced, still being coveted and preserved and studied 30 years after the first one left the factory. It endured because it deserved to, and it deserved to because it was built from its very first day of development to be worth enduring for. That is everything. 100 facts about the MK4 Toyota Supra across 12 segments, from the first design meeting in February 1989 to the cars still turning laps on tracks today. If you are still awake, thank you for listening carefully. If sleep found you somewhere along the way, somewhere between the weight distribution figures and the production numbers, somewhere in the resonance chamber of the rear, spoiler, or the quiet hum of a 6-gear cruise, then the car kept you company as you rested, and that seems like exactly the right thing for it to have done. It has always been that kind of car, capable of more than you asked of it, present and dependable, and still there when you return to it. Rest well. The Supra will be here when you wake up.